Okay, let's read through it. It says the blades of an electric fan rotate clockwise. So I do see that picture. It says it completes 5 rotations every second. So let me write that down for you. So it's going to be 5 rotations every second. All right? Then someone says, how long would it take to do one rotation? One rotation would occur 1/5 of a second. All right? So one rotation would occur, well, 1/5 is going to be, let's see, that's 2/10, so 0.2 then, right? 0.2 seconds. All right? So I kind of understand that. It says point B is the tip of the fan. I do see that. All right? And the fan blade is located directly above the center of the fan at time t equals 0. So I'm going to say we're starting out at t equals 0. So at t equals 0, the tip is up here. All right, let's keep reading it. It says point B is 6 inches from the center. So they're telling me that this over here is 6 inches. All right, I can read that part. I got that part covered. The center of the fan is 20 inches. So this is 20 inches over here. So now I know at t equals 0, that point B from the table over here is going to be 26 inches. So I'm going to say the height of it, of that tip there, is going to be 26 inches. And this is t equals 0 seconds. H would be 26 inches above the table. Right, so I kind of understand, but I don't know what the questions are yet. It says, the center of the fan, 20 inches above the table, as the blade rotates, constant speed. I'm glad to hear that. The distance between B and the surface table periodically decreases and increases. Right, that makes sense. So as that thing goes around and around, it's going to go back and forth. And what's the most it could be? Well, 26 inches above the table. What's the least it could be is 20 inches above the table. That's the tip of the fan, by the way. So let me just kind of go through. I kind of understand what I just read, but it already says the graph of H is indicated over here, and it says 5 points, F, G, J, K, and P are labeled in the graph. No scale is indicated, and no axis is presented. And that's true, I don't see it. Determine the possible coordinates of H of T. Well, you know what, I got one of them down. Right, what's this one over here? I'm going to say this would be at t equals 0, you'd get H is 26. Right, I'm going to write this as a point though, and I want to point out what the points are going to be. They're going to be an ordered pair. The ordered pair is going to be T, comma, H. So this point over here, I'm going to say is 0, 26. As I look at this, I want to go to the next over here, and someone says, well, what's it going to be? Well, remember, it does one rotation every 0.2 seconds. I'll put this over here. It's going to be back at 26. Now, the question becomes is, what's going to happen over here? And that's going to happen at a half of a rotation. And that would be at 0.1 seconds. So this is 0.1 seconds. And what would that be? That would be 20, right? Now, I hope you realize that these guys are going to be centers. And this is good because we really get the 5-point technique of graphing over here. And I want to see if I can do that. And looking at it, I got to be careful with the numbers over here. And the first thing I do is put the T down. Oh, you know what I could do first? I know the center of it, by the way, and the center is going to be, if you're 20 to 26, that's going to be 6 units, right? Did I do that right? It's not 20. The center of the fan is 20. So I'm sorry, that would be 14. Sorry about that, I gotta correct that. I'm glad I looked at that. All right, sorry about that. So 14 to 26, that would be 12. So there's 6 units, which makes sense to me. That's why I had to rethink this, by the way. If you want 6 units up from 14, you'd be at 20. So I know these points over here are at 20. Let's do the time now. So it's going to be dead center between 0 and 0.1, which would be 0.05. All right? So let's take a look. Counting over 0, 0.05, 0.1, and this would be 0.15. All right? So the points are as follows. We did that. We got this point. That's the beginning. This is the end point, which I got this over here. And we'll make sure I labeled all the points for you. We got this point. I got this point, and I got this point. Let me just say, make sure things are equally spaced and I got the numbers right. So, 0, 0.05, 0.1, 0.15, and 0.2. And this is one cycle of, looks like a cosine function to me, all right? But they're writing down sine function. That's fine, by the way. I can do that too, because the sine and cosine are just shifted. And so I'm going to put over here, I think I did part A okay. And part A says, you know, the graph is indicated, and I think I did that. And what they want to do is, I did A, I think I did it anyway. I want to go to B, and B says the function can be written as a model with the sine function. And let's go through that with you. And looking at that, what I'm looking at is the sine function. And the first thing I want to do is the amplitude of it. And the amplitude of it, well, the distance between 14 and 26 is going to be 12, and half of that is 6. So I think I can write that part down. And let me write that down for you. So I'm going to write down h of t. I'm going to say amplitude is 6. Sine. And I'm going to put this over here. And then the next thing I do is I think I can put the, the next thing down. They say what the model looks like. And I got to get this plus d part over here. And there is going to be a shifting up of it. And we'll talk about that in a second. But I got to figure all these things out, by the way. So the first thing I do is I want to figure out the b. And how do I do that? It's going to be 2 pi divided by this length of the cycle. And that length's going to be 0.2. All right, I got to do that over here. It's going to be 2 pi. 0.2 is 2/10. All right? What does that give me? 10 pi. All right, I'll write this over here. 10 pi now. It's going to be 10 pi t. All right? So let's write that down. So I got it. You know what? Maybe I'm jamming that in too much. Let me see how they wrote this down. Oh, you know, they wrote it down in a strange way. I could get my eraser out, and they did write in a strange way for me. I wasn't expecting to see that. But anyway, before I do that, what I'm going to claim over here is, I'm going to get to that strange way in a second, but I want to write this h of t down the way I like to write it down. So again, I got the amplitude as being 6, and I'm going to say sine of 10 pi t plus some shifting of it, all right? And I'm going to say they shifted it by, let's say, because the sine function, if I thought about the sine function looks like this over here. So they kind of shifted it over, all right? How much did they shift it over? I'm going to say pi over 2, all right? Pi over 2, right? But I'll get this thing later, but right now I'm going to try to get this h of t down to look like their h of t. It's going to be 6 sine, and I'm going to factor that now. I'm going to factor out 10 pi. So 10, because they get a t there, right? This is 10 pi. T, well, let me put this down. So it's going to be 10 pi times something, right? They're calling it, what are they calling it over here? I think they're calling it c. So I got to figure out what number, 10 pi times what number would be pi over 2. And that's going to be, let's see, that's going to be, the pi's cancel, and you get 1/20th, right? So 1/20th. Right, I'm going to write it as a decimal, though. 1/20th is going to be 5 over 100, which is 0.05, all right? Again, I still have to worry about this guy over here. Let me kind of clean it up a little bit. H of t is 6 sine, and this is going to be what? 10 pi t plus, and that's going to be, I just said it, right? 0.05, right? Now let's do this other thing, and they got over here, with this guy over here, and I want to point out, at 0, this thing evaluates to something. And what's it going to evaluate? It's going to evaluate to 26. So I want to point out, if I were to plug the 0 in over here, you would get, 0.05 times 10t. Let me write this over here. So 5/100 times 10 pi. And what do you get there? Well, 10 goes into 100 10 times, and you get pi over 2, which is what I was expecting, by the way. And the sine of pi over 2 is 1, so you get 6. And it should be 26, so there's got to be 20 over here, all right? That makes sense, all right? So I think I got that part done, all right? That part, I got the h of t down. So I write that over here. And so far, everything is done by hand, by the way. Everything. I got this over here. So let's see, write the function down. I did that. Now it says refer to the graph in part H. I'm sorry, graph H in part A. The t coordinate, K, is T1. Oh, I see that, T1. This is T1 over here. And the t-coordinate of P is T2. Where's P? Oh, this is T2. All right? So the question is, you know, the function h can be, I'm sorry, the graph of the coordinate T1, T2. On the interval from T1 to T2, which of the following is true about h? All right? Let's take a look at it. And it says in the interval from T1 to T2, let me just outline that for you. This is over here. And again, I'm not using a calculator at this point. What can I say about it? H is positive and increasing. All right? So I'm going to say, you know, on this interval, H is positive and it's increasing. So I can say that's true. H is positive and it's increasing. All right? H is positive and decreasing. I can't do that. H is negative increasing. No, H is negative. So the only answer there is A. A is the only answer I could choose over there. All right? So let's take a look at the next one. What's the next question? Describe the rate of change of H is changing in the interval from T1 to T2. All right? Now, I'm looking at this thing over here, and I want to point out the rate of change over here, the slopes are all going to be positive. All right? However, it seems like it's starting off and the rate of change is great here, and then what happens over here, if you look at it, the rates of change appear to be getting less and less. All right? So I'm going to say it's the most at T1, and it starts to decrease over time, by the way. And by the way, we can certainly determine about the concavity of it, and the graph is concave down over there. So I can say the rates of H are decreasing at on that interval. All right? Let me see if there's other questions over here. Describes rate of change, and I think that's about it. Let me just take a look at 4. Let me just see if I did that. I think I'm done with 3. Let me make sure that I'll look at it and see if that's done. And I really didn't need a calculator for that, which is good news for me, by the way. Let's see if there's any other questions over there. And let me take a look at it. 4, the directions, also specified. No other questions there. We're done with that question. I did not use a calculator on it. Thank you.